Heyo! So for these last couple videos, we're going to talk just a little bit about trigonometry, which is the study of triangles. You cover this in geometry, quite a bit, but we're just going to kind of hit some of the highlights of trigonometry because it does, it shows up so many places in the real world as far as, or as well as future math classes. So today we're going to start by talking about the Pythagorean Theorem. EQ is what is the Pythagorean Theorem, and how do I use it to find sides of a triangle? So just to kind of recap, what is this shape? I think we all know it's a triangle because it has three sides. This little box in the corner tells me it is a right triangle, meaning that angle is 90 degrees. All three angles in a triangle have to add up to 180. All three angles add to 180. That'll be helpful later on in probably the third and fourth video. But for today, all we're going to do is focus on the sides of the triangle. And so what we know about in a right triangle, we have a special name for this. The side that is the longest, and the longest side of a right triangle will always be the one that's across or diagonal from the 90-degree angle. So if you see the 90-degree angle, the side that's not touching that angle will always be the longest side in that triangle, and that is called the hypotenuse. And then what I'm going to do is I'm going to just call these other sides legs. Okay, sometimes it's base. We're going to use the word leg to describe that. And there's a very special and unique relationship that only works in right triangles. And that's what's called the Pythagorean Theorem. And that relationship basically says that if you take the two legs, however long they are, so 10 to whatever random numbers, hypotenuse. There's a relationship that says the first leg squared, so if you take that length squared, plus the other leg squared, has to equal the hypotenuse squared. This is often shortened. Instead of calling it leg and leg, because that can be confusing, we call it A and B. Then we call hypotenuse C. And then the Pythagorean theorem is written as A squared plus B squared equals C squared. Okay. And so this is true in every right triangle, and it is only true for right triangles. Yeah, so that's a very powerful fact, and we're going to use that to kind of determine if something's a right triangle, and then we're also going to use that fact to find a missing side length if we know we have a right triangle. Okay, so let's see how this works. If you're given a triangle like this and it says 5, 12, 13, now you were taught in geometry that if something looks like 90 degrees, you can't assume it's 90 degrees unless the marking is there. Now, I legitimately just forgot to put the markings, I think, in every single triangle in this video. So I'm just going to write this in. Well, no, that's not true because we don't know if this is a right triangle yet. That's the point of this, is I want to check to see, is this a right triangle or not? So I don't know if that's 90 degrees. So I didn't accidentally leave it off. It's intentionally left off. So we're going to test to see. If this is going to be a right triangle, the longest side would be C, which is the hypotenuse, and that's 13, which means these other two sides, it doesn't matter which one you call A and which one you call B. I usually go A is the smaller number, or the shorter leg, but it doesn't matter. So we're going to test to see, is this a right triangle or not? So I want to see, is it true that A squared plus B squared equals C squared? And if that's true, then this is a right triangle. So A is 5, so I'm going to take 5 squared plus B, which is 12 squared, equals C, which is 13 squared. Okay, now I can leave the triangle behind, and let's just see, is this the same on both sides? 5 squared is 25, 12 squared is 144, and 13 squared is 169. So the question is 25 plus 144 equal to 169? And sure enough, if I add those together, I do get 169. Since it's the same on both sides, what that tells me is that this is a right triangle, because it was true that a squared plus b squared equals c squared. Okay, so that's how we're going to check to see if something is a right triangle. We're going to just, you can't do this unless you have all three sides. You can't check for a right triangle unless you are given all three side lengths. So here, if I do the same thing, a, b, and that would be c, 6 squared plus 7 squared equals 9.4 squared. Now, with Pythagorean theorem, you are going to see a lot of decimals, so don't be shied away by that. Just have a calculator handy, like I do here. 9.4 squared, 88.36. Already, it doesn't look like it's going to work, because if I do 36 plus 49, I get 85. Now, if it was like, if they were super close to each other, like off by 0.01 or 0.001, then we could probably say it's a right triangle because it's a rounding thing. But 85 is clearly not close to 88.36, so this is not a right triangle. That means it would either be acute or obtuse, and we're not going to talk about that. We're only going to focus on right triangles. So how can we use that same idea of Pythagorean theorem to find a missing side length if I only have two? Now note here, this triangle is marked with the right triangle box. So we know that is a 90-degree angle. So now I know I can use a squared plus b squared equals c squared. Again, across from the 90 is always the hypotenuse, or what we would call c. So these other two will be a and b. So in this case, I want to figure out how long is the hypotenuse of this triangle. So I have 6 squared plus b, which is 10.3 squared equals c squared. So I know 6 squared is 36, 10.3 squared. 106.09 equals c squared. Now, if I add those two up, I'm going to take that number plus 36. I get 142.09. Now, we know algebraically to get rid of a second power, or to get rid of squaring something, I'm going to square root both sides. So I need to take the square root of 142.09. Oops, 142.09. And then you get this big long decimal. Now, here's how I'm going to do this problem. Be careful with what the problem's asking. If it says round to tenths, round to whole, round to hundredths, thousandths, because this side of the triangle was given to the 10th place, 10.3, right? Tenths meaning only one number after the decimal point. I'm going to do the same thing for this. So 11.92, the 2 does not round up. It actually keeps the 9 the same. So 11.9 would be my missing side length. So that hypotenuse would be 11.9. A smart thing to do to check is just make sure that your hypotenuse number that you got is bigger than the other sides of the triangle. Okay, sometimes weird things can happen. Your longest side of the triangle should always be the hypotenuse, and sure enough, if I put in 11.9, it's the longest side of the triangle. So I know I'm good there. So now I want the same idea, but now instead the missing side. We have the hypotenuse. Now I want to find one of the legs. Again, the 90-degree is marked here, so I know this is side C. I don't know which one's longer. Visually, it looks like the 19 is going to be the short leg, and then this is going to be the long leg, but these things are usually not to scale. So, all right, so 19B. So I have, if I'm setting up my Pythagorean theorem, I have 19 squared plus b squared equals 43.5. squared. 19 squared and through 289. Oh, my God, 361 plus b squared. Trying to be cool and do math in your head, Luca. Nice job. 43.6 squared is 1900.96. All right. So then if I'm going to, now what's different here is I'm solving for b. So I can't just square root right now because I still have that 361 on the left-hand side of the equation. So I'm going to move that over or get rid of it by subtracting it to both sides. Then I'll be left with b squared equals 1900. I'm not going to try and do mental math anymore. Just going to use the calculator. 361, 1539.96. Okay. Now I'm going to go ahead and square root both sides. So I'm going to square root that number. It's, again, since 43.6 was given to the 10th place, I'm going to go ahead and round to the 10th. So b is going to be 39.2. And so if I put that in, I should see that the side that I found has to be shorter than the hypotenuse, and sure enough, it is. So Pythagorean theorem to find, to check for right triangle, Pythagorean theorem to find a missing hypotenuse, Pythagorean theorem to find a missing side length. Go ahead and pause the video real quick, try these two, and then we're going to wrap this up. All right, so I rotated this on you a little bit. So the 90-degree across, so I do have A and B in this problem. I'm trying to find what C is. So 14.6 squared plus 15.8 squared equals C squared. I'm going to go ahead and round this one to the hundredths place for no real good reason other than both of these are decimals, and I just want to get used to rounding to different, tenths, hundredths, thousandths, so on. So 14, I'm going to go ahead and just add these together right away. Plus 15.8 squared. So 462.8 equals C squared. And if I square root that number, 21.51. It'd be 21.5 if I was rounding to the 10th place. Again, it's arbitrary why I picked hundredths. I just want to kind of mix things up a little bit. So that was 21.51. And then finally here, this is another, it looks to be that we do not have the hypotenuse. So I have A of 1.7 and B of 1.9. 1.9 squared equals C squared. 361 plus 289. It's going to be like, I don't know, 6 point something. 6.5. 6.5 equals C squared. And then if I square root 6.5, 2 point something. 2.549. So here's where if I was rounding to the hundredths place, the hundredths place is right here, the 4, but the 9, the number right after it, is 5 or above, so that would round that up to 2.55. If I was rounding to the 10th place, it would just be 2.5. But again, just want to keep things mixed up a little bit. So that is our Pythagorean theorem. How do I use it to find sides of a triangle? A squared plus B squared equals C squared, where C is the hypotenuse. And this only works for right triangles. That's going to do it for this first one. 3 more, and we're out of here. Out of here.